Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about states of matter. In this video, we will consider common states of matter, kinetic description of states of matter, solid states of matter, liquid state of matter, and gaseous state of matter. Common states of matter. Matter is anything that has mass and occupies space. There are three common states of matter. Number 1 solid, number 2 liquid, and number 3 gas. Now, solid state of matter. In solid state, molecules or particles are tightly packed with one another, and they have only back and forth motion, that is vibrational motion, about their fixed positions. Therefore, particles in solid cannot slip or slide over one another, and thus they possess definite shape and definite volume. It is the intermolecular structure of solid. Number 2, liquid state of matter. In liquid state, molecules are not tightly packed with one another. Their positions are not fixed and they can move in all directions. Hence, liquid does not have any definite shape, but in liquid state, the kinetic energy of molecules is less than gaseous state. Therefore, intermolecular attractive forces are more than gaseous state. Due to these intermolecular attractive forces are more than gaseous state, so therefore due to these intermolecular attractive forces, liquid has a fixed volume. It is the intermolecular structure of liquid. Having no definite shape, liquid acquire the shape of container, but liquid has fixed volume. Number 3, gaseous state of matter. In gaseous state, molecules are lying away from one another and they can move in all directions easily. The cohesive forces in a gas are negligible and the particles are free to move about in all directions. The kinetic energy possessed by these molecules are very high. Therefore, gases have neither definite shape nor definite volume. It acquired the shape and volume of container. Now, kinetic description of states of matter. According to kinetic molecular theory, matter is composed of very tiny particles which are called as molecules. These molecules are always in motion and they possess kinetic energy. The three states of matter depend upon the arrangements, motions, and forces of attraction between these particles. It is the solid, liquid, and gases. the kinetic energy of solid is less than the kinetic energy of liquid is less than the kinetic energy of gases. Gaseous molecules possess high kinetic energy, and the distance between particles of gaseous molecules are very large as compared to liquid, and the distance between the particles of liquid are larger than the solid. Now, interconversion of three states. Most of the important properties of liquids, solids, and gases depend upon the interconversion of one state into another state. If we heat solid, it converts into liquid, and if we heat liquid, it converts into gas. For example, when ice is warmed, it melts into liquid state, that is water. When water is heated and boiled, it changes into vapor, that is gaseous state. Solid ice can be converted into liquid water, and after heating, this liquid water is converted into gas, that is water vapors. Solid, liquid, gas. Melting and boiling point. If heating is continued, then at certain temperature, the added energy becomes enough to overcome the attractive forces holding particles of solid in their fixed positions, and it starts melting. The temperature at which solid starts melting is called melting point. If we heat solid, it converts into liquid. The temperature at which solid starts melting is called melting point. For example, the melting point of water is 0 degree centigrade. Now, boiling point. A certain temperature, the vapor pressure of liquid becomes equal to external pressure, and at this temperature liquid starts boiling. This temperature is called boiling point. Boiling point is the temperature at which the vapor pressure of the liquid becomes equal to the outer atmospheric pressure. At this temperature, the liquid starts boiling. Now, sublimation. When water is heated and boiled, it changes into vapor, that is gaseous state. Some solids, upon heating, instead of changing into liquid state, are converted directly into gaseous, that is vapor state. This process is called sublimation. Sublimation is a process in which solid directly changes into gaseous or vapor state. For example, naphthalene balls, sublimation of naphthalene balls. Now fusion. At melting point, solid particles lose their fixed positions as well as their arrangement, and the solid is converted into liquid. At melting point, the temperature of solid and liquid remains same until all the solid is melted though heat. It means in this condition, the rise in temperature is used in change of state from solid to liquid, and this change is called fusion. Temperature is used to change of a state from solid to liquid, and this change is called fusion. Now evaporation. When liquid is heated, the kinetic energy of liquid molecules increases. Due to increase of kinetic energy, certain molecules start escaping from the surface of liquid, and this escape of molecules is called evaporation. During evaporation, surface molecules starts escaping from the surface of the liquid. Vaporization. At boiling point, bubbles of vapors can form within the interior of liquid and then rise to the surface, where they burst and release vapors, and thus liquid is converted into gas, and this change is called vaporization. The bubble of vapors can form within the interior of liquid and then rise to surface, where they burst and release vapors, and thus liquid is converted into gas. Now diffusion in gases. The spreading of a substance through a medium like air or liquid is called diffusion. The rate of diffusion of a substance depends upon molar mass or density. A Scottish chemist, Thomas Graham, in 1846 studied the rate of diffusion of different gases and formulated Graham's law. It states that the rate of diffusion of gas is inversely proportional to the square root of its molar mass or density. We can easily observe that rate of diffusion of hydrogen is greater than the rate of diffusion of oxygen gas, because the molar mass or density of hydrogen is smaller than oxygen. Hydrogen, oxygen. Rate of diffusion of hydrogen is greater than the rate of diffusion of oxygen. Now, diffusion in liquid. According to kinetic molecular theory, matter is composed of very tiny particles which are called as molecules. These molecules are always in motion and they possess kinetic energy. The three states of matter depend upon the arrangement, motions, and forces of attraction between these particles. In this experiment, we have taken a beaker filled with water. Then we add some colorful liquid in it with the help of dropper. After some time, we observe that the colorful liquid diffuses and finally form a colorful solution. Now, Brownian movement. This property was first observed by British botanist Robert Brown in 1827. During the movement of pollen grains in water by microscope, if a drop of liquid with particles suspended in it is observed under a microscope, it is seen that the particles are not at rest but they are moving in all directions in zigzag motion. This motion is called as Brownian movement after the name. We observe it, a continuous rapid zigzag motion of suspended particles through the medium is called Brownian movement. Example for Brownian movement. Mix some powdered sulfur in water and stir it. After stirring, filter the suspended sulfur. Some of the sulfur particles are very small and they can pass through the pores of filter paper into filtrate. Now put a drop of this filtrate on a slide and examine it under high-powered microscope. It is observed that sulfur particles perform rapid random zigzag motion through the medium and this motion is called Brownian movement. Now, thank you very much. Allah Hafiz.